Mercury is a chemical element with the symbol Hg. It's also known as quicksilver and was formerly named hydroargyrum, which comes from the Greek words hydror and argyros. It's a heavy silvery element, which is the only metallic element that is known to be liquid at standard conditions. The only other element that is liquid under these conditions is the halogen bromine, though other metals such as cesium, gallium and rubidium melt just above the room temperature. Mercury is used in thermometers, barometers, manometers and sphygmomanometers. Mercury is electrically conductive, so mercury finds use in many switches, mercury relays, fluorescent lamps and other devices. Although because of mercury's toxicity, mercury thermometers and sphygmomanometers have been largely phased out in clinical environments. The most famous or infamous use of mercury is as a preservative in vaccines. Some time ago a document surfaced that the mercury preservative in vaccines causes autism in children. However, that document was found to contain many factual and logical errors, making it one of the biggest conspiracy theories ever. While the mercury preservative in vaccines is quite toxic, there's a really small amount of it, which means that, for example, you'd have to have a dose that is probably 100 times more than the vaccine to actually have any kind of side effects. Generally, to extract a pure element we need to have a source of it, like a salt or an ore. For me that source is some mercuric oxide that I've bought from a local company. Okay, so to begin, mercuric oxide is insoluble in water, so I've had to turn it into a form that is soluble. First, to a 1 liter beaker I've added 125 grams of mercuric oxide. After addition, I've started periodically adding concentrated hydrochloric acid. The acid reacts with the mercuric oxide, turning it into mercury chloride, which is more soluble in water. As you can see, as I add the hydrochloric acid, the red salt disappears because it gets dissolved into solution. Also, for some reason it turns black, which I'm not sure why. If you know why it does, you can leave an answer in the comments. After it has dissolved, aluminum was added into the solution. As you can see, the solution reacts vigorously with it, and what's happening here is some leftover acid and the mercury chloride reacts with the aluminum, forming aluminum chloride. So I've decided to leave it for 24 hours and I went to play some Fortnite. After I came back to it, it was just an ugly mess. It seems that the concentration of the aluminum chloride turned the whole solution into an ugly sludge. Now, if I've done everything well, the mercury should be at the bottom of the beaker. So to start, I've decanted most of the aluminum chloride sludge and put it into a separate beaker. And so I've grabbed a pipette and started extracting the mercury. As you can see, the mercury really likes to go out of the pipettes, so I have to transport the mercury out of the beaker as fast as I can, because if I don't, there will be a mercury spill, which all around is really hard to clean up. Anyway, after the whole process, this is the final yield. It's around 90 grams of mercury, which means that not all of it was extracted. So in the future, when I will get to it, I will go back and pull the rest of the mercury out. Remember, if you're going to try it yourself, mercuric oxide is extremely toxic on its own, and even prolonged contact with skin can result in death. Although mercury chloride is even worse because it's soluble and even more toxic. If you think about it, if mercuric oxide was PUBG, then mercury chloride would be Fortnite. Not only does it make you want to die, but it gives you cancer in the process. Well then that's my meta joke for the video. Anyway, these are the things that I'm currently working on. If you liked the video, remember to subscribe.